The topic of my lecture is capacitor. As you know, the capacitor is an electrical device which stores the electrical energy in the form of electric charges. The capacitor is composed of two plates, and both plates are connected to the battery. How capacitor work? The battery which is connected to the positive terminal of the battery, this plate will lose the electron. Suppose the 4 electrons are going out from plate, and these 4 electrons are going towards the other plate of the capacitor, and these 4 electrons will be stored into the other plate. The plate which is losing the electron, it will become the positive, and the plate which accepts the electron, that becomes a negative. Here I have written plates connected to the battery, electron leaving the plate, that becomes positive, electron receiving the plate is known as negative. When the plates are becomes charged, one is positive, other is negative, then there is an electric field produced between the plates. So there is a chance that the positive plate will attract the negative plate. So to reduce the force of attraction, we introduce some dielectric or insulating material. For example, glass, mica, plastic, etc. The charges stored in the plates is directly proportional to the potential difference applied. When we apply maximum potential difference, then the maximum amount of charge will be stored. If you apply low potential difference, then the low amount of charge will be stored. So mathematically we can write here the amount of charges Q is directly proportional to the potential difference. Now Q is equal to, here we apply a constant into V. So the Q is equal to C into V, where C is called constant known as capacity or capacitance of capacitor. The capacity of capacitor can be reformed as C is equal to Q upon V. Its unit is equal to Coulomb upon volt, and Coulomb upon volt will be equal to Farad. So the unit of the capacitor is called a Farad. I have a capacitor. You have seen this capacitor mostly used in the motors as well as the fan. So this plate is the positive, and now this plate is the negative, and these two plates are connected by the wire. Now I demonstrate that how the capacitor works. So I connect this capacitor with a battery. So suppose I have a battery. My dear students, now I joined the both wires, and you will see a similar light. Dear students, आपने अभी देखा होगा कि ये मेरे पास कैपेसिटर था, इसको मैंने चार्ज किया और उसके बाद जब मैंने दोनों वायर्स को मिला दिया तो आपने एक स्पार्क देखा होगा, और ये जो स्पार्क जो आपने देखा, एक्चुअली दिस इज द डिस्चार्जिंग ऑफ द इलेक्ट्रिक चार्जेस व्हिच आर स्टोर्ड इन द कैपेसिटर। कैपेसिटर को हम ऐसा यूज कर सकते हैं कि वो इलेक्ट्रिकल डिवाइसेस जिसको बहुत ज्यादा एनर्जी चाहिए, और उसके लिए हम कैपेसिटर इस्तेमाल करेंगे। फॉर एग्जांपल फैन को तो बहुत इलेक्ट्रिक एनर्जी चाहिए, तो हमारी जो आम जो लाइंस होती हैं, पावर लाइंस होती हैं, वो उनके पास तो तवानाई होगी, उस फैन को चलाने के लिए इतनी काफी नहीं होगी, तो फिर हम यहाँ पे कैपेसिटर यूज करते हैं ताकि ये कैपेसिटर एनर्जी को कलेक्ट करके और एकदम फैन को प्रोवाइड करेगा, और फैन वो एनर्जी लेके वो उसकी रोटेशनल काइनेटिक एनर्जी स्टार्ट हो जाएगी और फैन अपना काम करेगा। तो ये दिस इज अ वेरी important function of the capacitor. Simply it store charges and it discharges the electric charges when it is connected to the any other electrical device. Dear students, suppose I have a capacitor and this capacitor can work between 100 to 300 volt. Suppose this capacitor can work from 100 to 300 volt. Now I tell you about the capacitance, how the capacitance remains constant. So suppose we have two capacitors, capacitor number 1 and capacitor number 2. Now first we discuss the capacitor number 1. According to equation, C1 is equal to Q upon V. Q is the amount of charges and V is the potential given to the capacitor. Suppose we give the voltage 100 and the 200 electric charges will be stored. So the answer will be 2 farad. Now I told you the capacitor is working between 100 to 300 volts. Now we give 100 more volts to the capacitor. Then we see the what with the capacitance. Now voltage increase from 100 to 200. The capacitance will be the 400. Again the answer will be 2 farad. Now again we increase the voltage from 200 to 300. The amount of charges will be 600. So the answer will be 2 farad. So now this is C2. This is a C3. So we can say the capacity of this capacitor number 1 remains constant. Therefore, C1 is equal to C2 is equal to C3 is equal to 2 farad. Now we have a second capacitor. And now the second capacitor will also be working from 100 to 300 volt, but it will store some more charges. How? C1 is equal to Q upon V. Suppose we give 100 volt. Now it will store the 250. So the answer will be the 2.5 farad. We give 100 volts more to the capacitor number 2. 200. So the amount of charges will be 500. So the answer will be again 2.5 farad. Okay. We increase the voltage from 200 to 300. So the 750 amount of charges will be stored. So the capacity will be again 2.5 farad. So from the results, we can conclude that C1 is equal to C2 is equal to C3 is equal to 2.5 farad. Therefore, we can say that the capacity of the capacitor number 2 is constant, that is 2.5. The capacitance of the capacitor number 1, that is constant, 2 farad. these two capacitors are working at the same voltage, but their ability to store the charges are different. Capacitor number one has ability to store the charges, that is a 2 farad, and the capacitor number 2 ability is 2.5. So from this results we can say the C2 is greater than C1. Okay. My dear students, suppose if you have more than one capacitor, say for example you have 2 capacitors, you have 3 capacitors, you have 4 capacitors, then the question is how can we connect them? So there are 2 types of connection. So कॉम्बिनेशन ऑफ कैपेसिटर्स में हम पढ़ेंगे कि आप कैपेसिटर्स को 2 तरीकों से आप कनेक्ट कर सकते हैं. जो उसका पहला तरीका है वो है सीरीज कॉम्बिनेशन. सो फर्स्ट मेथड है सीरीज कॉम्बिनेशन. सीरीज कॉम्बिनेशन को समझने के लिए हम यहां पे अज्यूम करेंगे कि हमारे पास 3 कैपेसिटर्स हैं, तीनों की अलग अलग कैपेसिटी है. तो एक की कैपेसिटी C1 होगी, दूसरे की कैपेसिटी C2 होगी और तीसरे की कैपेसिटी C3 होगी और उनको हम सीरीज में कनेक्ट करेंगे. सपोज वी हैव 3 कैपेसिटर्स. Connected in a series. This capacitor is C1, this capacitor is C2, this capacitor is C3. सीरीज में हम कनेक्ट कैसे करेंगे, इसका एक तरीका होगा, ये आपके पास है पॉजिटिव टर्मिनल और ये होगा नेगेटिव. जो प्लेट कनेक्ट होगी पॉजिटिव से, उस प्लेट में से इलेक्ट्रॉन निकलेंगे. हम अज्यूम करते हैं कि यहां से 2 इलेक्ट्रॉन निकल गए, तो यहां पे 2 पॉजिटिव चार्ज जमा हो जाएगी और ये 2 इलेक्ट्रॉन्स यहां से निकलने के बाद ये इस पूरे सर्किट में से गुजरेंगे और ये इलेक्ट्रॉन्स कैपेसिटर नंबर C1 में आ जाएंगे. तो यहां पे 2 एक्स्ट्रा इलेक्ट्रॉन्स जमा हो जाएंगे. तो ये जो आपके पास प्लेट होगी ये हो जाएगी नेगेटिव. उसके बाद क्या होगा कि ड्यू टू इलेक्ट्रिक फील्ड, इफेक्ट ऑफ इलेक्ट्रिक फील्ड, यहां से 2 इलेक्ट्रॉन निकल जाएंगे. तो ये आपके पास 2 चार्जेस जमा हो जाएंगे प्लस के. फिर ये 2 इलेक्ट्रॉन्स जो होंगे यहां से निकलने के बाद ये अदर प्लेट में चले जाएंगे और ये आपकी प्लेट हो जाएगी नेगेटिव. और फिर यहां से 2 इलेक्ट्रॉन निकलेंगे, फिर ये इलेक्ट्रॉन ये प्लस हो जाएगा और ये इलेक्ट्रॉन्स इस प्लेट में जमा हो जाएंगे और ये आपकी प्लेट हो जाएगी negative. Now look at the figure. The 2 electrons are emitting and the 2 electrons are stored here. 2 electrons are emitting, 2 electrons are stored here, 2 electrons are emitting from here and 2 electrons are stored here. So the same amount of charge is stored in the series combination. So here the charge will be stored will be Q. Here charge will be stored will be Q. Charge will be stored will be Q. But remember, the potential difference across C1 will be equals to V1. The potential difference across C2 will be equal to V2. And the potential difference across C3 will be equal to V3. So here we got 2 points. Number 1, same amount of charge stored. Same amount of charges stored. Point number 2, different amount of potential difference will be produced across each capacitor. Now we use the fundamental equation of capacitor, that is Q is equal to C into V. Now V is equal to Q upon C, V1 is equal to Q upon C1, V2 is equal to the Q upon C2, and the V3 is equal to the Q upon C3. Same amount of charge will be stored. That's why I write Q upon C1, Q upon C2, and Q upon C3. Now these three capacitors will not work differently, but remember, these three capacitors will work as a single capacitor, and we say that that single capacitor will be known as the equivalent capacitor. So if I replace these three capacitors by one capacitor, then what happens? This is the single capacitor, and this single capacitor will be known as the equivalent capacitor, and its capacity is known as the equivalent capacity, and our object is to calculate the value, to calculate the formula of the CE. Now our object is to find out the CE. Okay. The total capacity, as I told you, this is the object of this lecture. CE we have to find. So the total capacity can be found by the equation of the capacitor, that is V is equal to V1 plus V2 plus V3. This is the VE. Now this voltage is across the first capacitor, V2 across second capacitor, and V3 across the third capacitor, and this voltage is the voltage across the equivalent capacitor. So the VE is equal to Q upon CE is equal to V1 is equal to Q upon C1 plus V2 is equal to the Q upon C2 is equal to Q upon the C3. So the Q upon CE will be equal to, the Q is the common, so the 1 upon C1 plus 1 upon C2 plus 1 upon C3. So the Q will be cancelled. So the 1 upon CE is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Consider we have more than 3 capacitors. Suppose we have a number of capacitors, then this equation can be expanded as 1 upon CE is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus 1 upon C4 plus 1 upon C5, going on up to 1 upon Cn. Dear students, the second combination of the connection of the capacitor is the parallel combination. In the parallel combination, remember, the voltage across the terminals will be same, but the amount of charges will be different. So now we have 2 points here. Point number 1, same potential difference or voltage, across each capacitor, but different amount of charges will be stored. Amount of charges will be different. These 2 points of series combination and parallel combination are very important for the pre and test. Okay. Now these 3 capacitors will not working independently, but they will working as a single capacitor. So I write that suppose this is a capacitor which is equivalent to this combination. Now this capacitor will be indicated by CE and the voltage is V. Okay. Now according to the basic equation of capacitor, the Q1 is equal to C1 into V. The charges across second capacitor, the C2 into V, and across the third capacitor is equal to C3 into V. In the figure, the first capacitor loses 3 electrons, second capacitor loses 2 electrons, and the third capacitor loses the 4 electrons. So the 3 charges will be stored in the first capacitor, the 2 charges stored in the second capacitor, and the 4 charges will be stored in the third capacitor. So remember, the amount of charges stored in each capacitor will be different. So the Q1, Q2 and Q3, the amount of charges stored in this capacitor is a QE. So the QE will be equal to CE into V. I told you earlier that this capacitor is equivalent to this combination. So the QE is equal to the Q1 plus Q2 and plus Q3. So Q is equal to CE multiplied by V is equal to C1 into V plus C2 into V plus C3 into V. So what is common here? V is common. So V is equal to C1 plus C2 plus C3. So what will be the next step? Yes, the VV will be cancelled. So the equivalent capacitance CE is equal to C1 plus C2 and plus C3. Suppose we have a multiple capacitors, then for multiple capacitors, CE is equal to C1 plus C2 plus C3 plus C4 going on up to the Cn, where n is the number of capacitors. Now I compare the two results. Now according to series combination, the total capacitance C 1 upon CE is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, and the parallel combination is CE is equal to C1 plus C2 plus C3. Suppose we have 3 capacitors. C1 is equal to 1, C2 is equal to 1, and C3 is equal to 1. these capacitors are connected in the series combination, then what will be the capacitance? So the 1 upon CE is equal to 1 upon 1 plus 1 upon 1 plus 1 upon 1 is equal to 1. So the CE is equal to 1. Okay. Suppose these capacitors are connected in the parallel combination. So 1 upon, CE is equal to 1 plus 1 plus 1. So CE is equal to 3. If I compare the results, series combination and parallel combination, so the parallel combination, capacity in the parallel combination is greater than the capacity